Here's a brief example using a function we've seen previously where the limit doesn't exist. In this case, I've taken the limit as x approaches 0 of the absolute value of x divided by x, and I've made the claim that it's equal to 0. What I kind of said was, well, we approach negative 1 from the left and we approach positive 1 from the right, so if we take kind of the average of those two things, we end up with 0. This is false. Please understand that this is definitely false. All right. I'm going to write that down to make sure we understand this is false. And we're going to see that the definition of a limit kind of leads us to exactly that same kind of a conclusion. So let's say that we pick epsilon to be some specific value in this case. Let's say that somebody picks that epsilon is equal to 0.1. And that's actually a pretty big value for epsilon. That says that the absolute value of x divided by x in absolute value has to be less than 0.1. Or we could write that negative 0.1 has to be less than the absolute value of x divided by x has to be less than 0.1. But we've seen that the only possible values that this function can take on are exactly negative 1 and exactly positive 1. That is, there's no value of x that we can ever pick that puts us between negative 0.1 and positive 0.1. There is no delta that will ever work. It's impossible to find one. So here's an example of where the Epsilon-Delta definition of a limit, that is this formal definition of a limit, can be used to show that something doesn't work. Just to remind you really quickly, if we pop over and take a look at a graph for a second, this again was a graph of that function. So what we were saying was that epsilon, that's on the y-axis, is negative 0.1 to positive 0.1. And we have to find a delta such that any x value we pick that's between negative delta and positive delta in this case, since x is 0, would lead us to a y value that's somewhere between negative 0.1 and positive 0.1. And as you can see clearly from the picture, the function never takes on values like that. It only ever takes on a value of negative 1 and a value of positive 1, nothing larger, nothing smaller than 1, nothing larger, nothing smaller than negative 1 over here on the left. We can't do it. That limit does not exist, and the definition verifies that.